And here it goes, just right out here. Well, then we decide, well, let's cool it down now from this temperature. All right, this is the cool down. All right. Now, unfortunately, when you start to go backwards, wherever you're at when you start, that becomes 100%, because you're going this way now, okay? So really ignore what this reads over here. The important thing is, wherever we were where we stopped the other graph, that's where we start this graph cooling down. And we're cooling this direction, going this way. And look at this. Now, we're doing the cooling at 2 degrees per minute, which is very slow. When you're at 800 degrees, 2 degrees per minute, there's a lot of minutes. Between there and there is what?
610 to 4,
to 340 to 350. You realize how long that is?
centigrade.
Yeah, degrees centigrade, yeah. Laboratory people always talk in centigrade. I grew up with Fahrenheit, but all the laboratory people talk in centigrade. Anyway, you realize where that goes. If you project that all the way up here, and then it collapses, look at how far that goes. Now, everybody just said, well, there's something wrong with this machine. You know, something's gone wrong. There's just not reality here. And you know, that does happen. You know, so we said, we got to check this. But just out of curiosity, once it settled down here, this is actually the same place it ended before. See, we started right there to cool, and actually right there is stable. Other than that one hiccup, which lasted about 4 or 5 minutes, it's basically stable. I said, well, tell you what, don't take it out. Let's just heat it again. And all the time we're under at this inert gas, and it doesn't say what it was, what gas, but I'm sure it was helium. It was argon or helium, one of the two. So now let's just start right there, and let's heat it again. So this is now the starting point, 100%, which is actually 50-some%. Let's start again. We start heating, and everything's fine for a while, and then these hiccups start again. And then look right here at this hiccup.
Only they're going down.
Yeah, now this is going down. Now if you look at it, it's actually getting less and less and less and less and less weight, and then it goes right back to where it should be. And then less and less and less and less weight, and then it just collapses right back. Now this is a strange, I mean, you got to understand this is data, and it has to be, say, what does this mean? Anyway, and then as we're getting hotter, it's just jumping all over the place. Now these jumps right here, believe it or not, are taking probably at 1.2 degrees per minute, and we're actually going up about 40 degrees. So this was what, 40 degrees, 1.2 degrees per minute. How many minutes is that? Anyway, these little hiccups are a long time. Even though it looks like a little hiccup, it was actually down there for a long time before it came back to the level again. And this seems to be kind of a standard level in here that it always dropped back to, but it actually would do these things. And I said, all right, cool it down again. Let's just do this again. Well, the next slide, this is the second cooling. Now, when we started, it happened to be right there. Well, actually, it was actually on a less than the baseline point. So this is actually the baseline right here. Okay, but there's where we started. So it actually went way, 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 way up to there and then collapsed back down. Now that's 150%, which is actually about what we started with. These weights here are not real. It can't be real, right? But that's what it's reading. But look at how far they're doing it. It's actually down to almost 200 degrees before it quits doing it. And the poor girl running this thing is just saying, this can't be. This just can't be. I said, well, tell you what, let's just keep going. Well, you imagine we killed like half a day already, you know. Let's go again. Just heat it again. So let's go to the next slide. All right, this is the third heating. You start off heating and everything is going along fairly stable, and then they start. And then look at this one right here. It weighs less than nothing. It doesn't weigh nothing, it weighs less than nothing. And let me tell you something, people. This is a Pyrex glass. You can see right through it. It's clear like a window. But when there is less than nothing, we look in the pan, there's nothing in the pan. Well, there's a reason for it, and what it is if you understand about superconductivity and flux fields, it's actually a flux field that we're talking about here. And it's building a field, and then when it collapses instantaneously, and then it starts building again. And then it collapsed instantly, and then start building again. But it actually is flux that is interacting with magnetic field. However, the magnetic field is not supposed to exist here because this machine has bifilar wound heating elements, and there's no magnetic field produced by the machine per se. The only magnetic field we're talking about is the Earth's magnetic field. So I said something just didn't make sense. Well, it really wasn't that after all, but I'll get to that in our presentation here. All right, let's go again. This is the fourth heating. And you can see by the time it gets up to around 200 degrees, it's starting to do this. Now, 200 degrees, and look, it's weighing less than nothing. If the pan was in it, the pan is zero. And it weighs less than the pan weighs if it didn't have anything in it. Once again, and it's not there. You cannot see it in the pan. It's gone. And its weighable mass is gone. And the pan it's sitting in's mass is partly gone. Now that's spooky. All right, cool it down. Now, once again, we started it, so it was way down here. So anyway, this is the cool down. And look at these peaks that are going on. But you see that every time we do it, we're moving this further and further toward ambient temperature, is the point. By annealing it, we're actually coming closer and closer and closer to room temperature. Anyway, let's go. Do we have any more in this now? There should be a fifth one.
Yeah.
Let's go to the next one. All right, here's the fifth heating. And then we have a fifth cool down. And this is the fifth cool down. Anyway, this material was just mind-boggling. We must have ran this 80 or 90 times. We actually ran it, and before we finished, we actually devised a little finger we could put inside the machine that when the material was gone, it would wipe through the pan and come back, just like a windshield wiper, to ensure that maybe it was there and just vibrating at frequencies we couldn't see with our eyes. So he wiped through the pan and then brought it back, and it was there. So it really left.
It hadn't moved.
It really was there, just not in these three dimensions. This is really important information, people, because the weight that we end up with here at the end versus the weight we started with is actually, reduces to like 56, 57% of the original starting weight. Now, just for the record, we take this material that weighs 56% of the metal, and we devised a way to take it back to metal, and when we take it back to metal, it weighs the 100%. And this is really perplexing for a trained chemist because he has to have a mass balance in all of his chemistries. And a mass balance, that's one of the things they teach you in the very beginning of chemistry. Keep a mass balance. And if you start with 100, you have to have 100 all the way through, and anything you add, you have to add to it. But you don't get less. And when it went from 100 to 55, 56%, this just really upset his apple cart. He said, Dave, this is not the physics that we have been taught in school.